Let us perform the titration of potassium permanganate solution with the help of standard solution of Mohr salt. Now here first of all you have to rinse the burette. I have taken 25 ml burette and then I have added a small amount of potassium permanganate solution and I am rinsing the burette such in order to remove the water present on the inner wall of the burette and throw the solution after rinsing into the sink and clamp the burette on the burette stand, and then you have to fill the burette with the help of potassium permanganate solution. Now I am adding potassium permanganate solution with the help of funnel. Now fill the burette with the help of potassium permanganate solution and you have to remove the air gap from the burette, and then you have to adjust the upper meniscus of the solution at the initial reading, that is nothing but the 0 mark indicated on the burette. Open the stopper and remove the air gap, and then you have to adjust the upper meniscus of the solution at the 0 mark indicated on the burette. Now here the initial burette reading is nothing but the 0 ml. Now for colored solution we always note the upper meniscus of the solution or the reading which coincides with the upper meniscus of the solution. So the initial reading is nothing but 0 ml. After adjusting the initial reading at 0 ml, then you have to rinse the pipette. Now here I am taking 10 ml pipette and I am rinsing the pipette with the help of standard Mohr salt solution in order to remove the water on the inner wall of the pipette such that it may not contaminate the solution or it may not alter the strength of the standard solution. Now you have to fill the pipette up to the mark indicated on the pipette and adjust the mark, that is the lower meniscus of the solution, up to the scratch mark indicated on the pipette. Here I am adjusting the lower meniscus of the liquid. Since it is a colorless solution, the lower meniscus will coincide with the scratch mark indicated on the pipette. Then you have to remove the pipette and transfer the solution into the conical flask. Now let the liquid fall into the conical flask, and for transferring the last drop you have to tilt the conical flask and touch the base of the conical flask once such that the last drop of the solution can be transferred into the volumetric flask, and then the total amount or the volume of Mohr salt solution transferred into the conical flask is 10 ml. Now I am adding 1 test tube full dilute sulfuric acid into it. You have to add 1 test tube full dilute sulfuric acid into it before titration. Now be assured that the initial reading is nothing but 0 ml indicated on the burette. Now then you have to open the knob and start titrating this solution present in the conical flask. Now add slowly the potassium permanganate solution with constant stirring. First of all, you add slowly with constant stirring. As you can see, the pink color appears and after stirring it disappears. Now this process will continue. You have to titrate it till the permanent pink color appears. So titrate it slowly by adding potassium permanganate solution with continuous stirring till the permanent pink color will be obtained, and that will indicate the end point of the reaction. Now this I am recording the first reading. So you can see that we get the permanent pink color, and then the endpoint has been achieved, and you have to note down the reading, that is the final burette reading. Now here the final burette reading comes out to be 10 ml. As you can see, the upper meniscus of the solution coincides with the mark indicated as 10 ml on the burette. Record this final reading of the burette. Here you can see the final reading is nothing but 10 ml. Now note down it into the observation table. Initial burette reading was 0 ml and the final burette reading is here, it is nothing but 10 ml. You can see the final burette reading is 10 ml. Exactly 10 ml. Now this is the initial reading. Now we get that the end point lies near about 10 ml. Now then you have to repeat the experiment again. You have to repeat this experiment again till the two consecutive reading remains the same. Fill the burette again and adjust up to the 0 mark indicated on the burette, and then you pipette out the Mohr salt solution, 10 ml of Mohr salt solution again, and transfer it into the conical flask. Now here I am transferring the 10 ml of the solution into the conical flask. Here I am adjusting the lower meniscus of the solution up to the scratch mark indicated on the pipette, and then I will transfer it into the conical flask again. Now transfer it into the conical flask. Always remember, you don't have to rinse the conical flask. It should be washed with water only. Always remember, the conical flask must always be washed with water. Now here I am transferring the last drop by touching the base of the conical flask with the tip of the pipette. Now add 1 teaspoonful dilute sulfuric acid into it. Here I am adding 1 teaspoonful dilute sulfuric acid. Now then you have to titrate this mixture with potassium permanganate solution. Now check the initial reading to be 0 ml and then titrate the solution. Now while recording the second reading, first of all you add slowly potassium permanganate solution with continuous stirring, and when the reading approaches to 9 ml, then you have to transfer just one drop by drop. Now here I am adding small amount of potassium permanganate solution with constant stirring, and you can see that the pink color appears, and after continuous stirring it disappears. This process will be continue, and you have to reach it up to the reading as 9 ml, approximately 9 ml. Because from initial reading we get that our answer lie between 9 and 10, or the endpoint lies between 9 and 10. Now after reaching the volume up to 9 ml, just add drop by drop. Now you have to add drop by drop with continuous stirring so that we can find out the color change by adding only just 1 drop of potassium permanganate solution, in order to get the exact endpoint. Now here you can see that after transferring just 1 drop of the liquid, the color changes from colorless to pink, and this will be the endpoint of the solution. Exact endpoint of the solution. You have to record the reading here on the burette. That is the final reading. Now here you can see that the reading comes out to be 9.9 ml. Initially we get 10 ml as the end point. and this second time we get the reading as 9.9 ml. Now, aim of the experiment was to prepare 100 ml of m by 10 Mohr salt solution, and using this solution you have to determine the molarity and strength of given potassium permanganate solution. Now next, let us draw the observation table. Before drawing the observation table, you have to report the two readings. That is nothing but the molarity of standard Mohr salt solution prepared. As you have seen in the previous video, the molarity of the prepared solution, that is standard solution, was nothing but 0.1048 moles per liter. Now second reading is that, or second observation is that, volume of Mohr salt solution taken during each titration is nothing but 10 ml. You have to report these two readings above the observation table. In observation table, you have to draw three columns. This column 1, 2 and 3. And here it is a serial number. The heading of the first column is nothing but the burette reading. You have to report the initial burette reading and final burette reading in ml. Now next you have to mention the volume of Mohr salt solution, volume of KMnO4 solution used during titration. And as you have seen in the video, the initial reading of the burette, that is initial burette reading, was nothing but 0.0 ml, and the final reading during first titration, the final reading was 10.2 ml. And here the volume of KMnO4 solution used will be equal to 10.2 minus 0 is equal to 10.2. Now next two reading are the two consecutive reading which remains the same, and they are known as concordant reading, and here the concordant reading is nothing but 9.9 ml as you have observed or seen in the video. Let us deal with the calculation part of the experiment. Before calculating, first of all you have to write down the balanced redox reaction for the given on which this titration is based. Now here 5 moles of Fe2 plus ion reacts with 1 mole of MnO4 minus ion in presence of 8 moles of H plus to give rise to the formation of 5 moles of Fe3 plus ion plus 1 mole of Mn2 plus ion plus 4 moles of H2O. Now for calculation we use the formula M1V1 upon N1 is equal to M2V2 upon N2. Now you have to describe what are these variables. So M1 is the molarity of Mohr salt solution that you have prepared, that was found to be 0.104 moles. Now volume of Mohr salt solution taken during each titration was nothing but 10 ml. Now here N1 is the coefficient of Fe2 plus ion in balanced redox reaction, and here the value is 5. Here the molar coefficient is nothing but 5 for Fe2 plus ion. Now next M2 is the molarity of KMnO4 solution that you have to determine, and V2 is the volume of KMnO4 solution used, that is nothing but the concordant reading. It comes out to be 9.9 as you have observed in the video. Now second, N2 is the molar coefficient of this MnO4 minus ion, and the value of this N2 is nothing but 1. So now next you have to substitute the variable in the above mentioned formula. Now and M2 is nothing but 0.104 multiplied by 10, that is the volume of Mohr salt solution, divided by the coefficient of Fe2 plus ion, that is nothing but 5, and it is equal to M2, which you have to determine, and the concordant reading, that is the volume of KMnO4 used, is equal to 9.9 ml divided by the coefficient of MnO4 minus ion in the above equation, that is the redox reaction, and it was found to be 1. On substituting this variable and calculating, we get the value as 0.0210 molar, that is moles per liter. So the molarity of KMnO4 solution will be equal to 0.0210 moles per liter. Now for calculating the strength of KMnO4 solution, you have to multiply the molarity of KMnO4 solution multiplied by its molar mass. Here the molarity of KMnO4 solution was found to be 0.0210 moles per liter multiplied by The molar mass of KMnO4 is nothing but 158 grams per mole, and on multiplying these two, we get the value as 3.318 grams per liter, and hence the strength of the given potassium permanganate solution will be equal to 3.318 grams per liter. Now, in the result, you have to report that the molarity and strength of given potassium permanganate solution is 0.0210 moles per liter and 3.318 grams per liter respectively. In this way, we can calculate the molarity and strength of given potassium permanganate solution. Thank you.